Hi everyone, thank you for joining us today. We are happy to present you the second live Sentinel Hub webinar. We will start in a couple of minutes with the presentation of OGC API and QGIS integration presented by my colleague Munia Shebila. After the presentation, the questions and answers section will follow. There are also a few of our Sentinel Hub team members present today to make sure to answer as many of your questions as possible. So now I'm giving the word to Munia.
Hello everyone. Before we deep dive into the OGC API, let me give you a short introduction on what API is. API means Application Programming Interface, and it is the interface that is in this case used to include satellite imagery into users' applications. This can be, for example, QGIS, ArcGIS, or users' own web applications or desktop applications that the users can then commercially sell to other users as well. Sentinel Hub supports two types of API. The first one is OGC API that we will be looking at today. And the other one is the Process API, which is a bit more complex. So the OGC API means Open Geospatial Consortium and is a well-established and commonly used API standard. A lot of people use it, and it is a bit simpler to use, but it is also less, it allows for less development and less features. So this is why we also developed Process API, which we are going to be taking a look at in our next webinar. For any use of the API, a subscription is needed. There are different packages available to suit your needs. One of them is a 30-day free trial, and if you do not yet have a subscription, I strongly recommend you to get a free trial account to try it out. So let's get started. We are going to be taking a look at first how to create configurations and layers in our configuration utility, and then how to view them in Sentinel Playground and your browser. Next, we are going to be taking a look at our Sentinel Hub documentation to learn how to understand the OGC structure and its examples. We will also be running OGC requests with URL, Request Builder, and Postman. Next, we will integrate OGC request into QGIS and ArcGIS Online. And then we will take a look at Python. First, we will take a look at how you can create OGC requests with Python, where you can find the documentation. And then we will very shortly take a look at the Jupyter Notebook examples, where the Wildfires use case was dealt with using OGC. Finally, as a little bonus, we are going to include satellite imagery into a web application using a Leaflet plugin. So I am now in the sentinelhub.com website. We're going to click on this little sign in button up here. We're going to sign in. Okay, so this is the configuration utility. Here you can store your configurations, which have the layers that you can create of the satellite images that you can then view and include into your applications. As you see, you can see a new configuration, blue button up here that we're going to click now, and we will create a new one. We will name it Agriculture Monitoring. This button down here allows you to create a configuration based on any of your other instances and a lot of templates that are already prepared for you when you create a new account. But right now we are going to create one from scratch. So I just clicked on the Create Configuration green button and I am transported into this layer section. There are a lot of options here, but for now you need to know that to create a new layer, you have to click on Add a New Layer up here, the green button. And then first, let's decide which layer we want to create. So for this one, I first want to create a true color layer. And next I have to choose the satellite or a data source. And as you can see here, all the data sources that are supported with API are listed here. This means all the Sentinels, MODIS, Digital Elevation Model, Landsat 8, and Bring Your Own Data. we're going to stay with the pre-selected Sentinel-2 L1C. So as you can see here, we are immediately prompted to add in a custom script or a data product so that we can tell the system how we want this data source visualized. I'm going to click on this little edit button over here, a little pencil, and then I have two options. I can choose a data product or a custom script. As you can see here on the left, we have quite a lot of data products already prepared for you. I'm going to choose a true color, RGB visualization, and as soon as I click Set Product button, it will then be set. I have some other options here. I can also choose a time range from and to. I can manipulate the cloud coverage and choose what kind of mosaic order do I want. Do I want least cloud coverage, or do I want most recent images to be displayed, and so on. I'm going to leave it as it is and click Save. Now we are going to very quickly create two new layers. The first one is going to be NDGI. Again, I'm going into data products and I will search for the NDGI and I will choose the green to white linear scale data product. Set and save. And then finally, we're going to create a layer called barren soil. And for this one, we're going to use a custom script. We will go on the custom script sentinelhub.com, where all of our scripts are collected. And we will quickly grab the barren soil script over here. If you are interested in custom scripts, in how you can create one, view our previous webinar on custom scripts. Set the custom scripts. Right, as you can see, the custom scripts I added into the right window over here, while the data products are displayed in the left one. I click on Set Custom Script over here and click Save. So now configuration agriculture monitoring is set. Next, let's take a look at how we can view this in Playground. So this one is pretty simple because you have a little handy button over here, open in Playground. And this will immediately transport you to the Sentinel Playground, where all of your layers are going to be displayed. And you can easily pan them, zoom or zoom out, and so on. Now, Sentinel Playground does not support all of the data sources anymore. So as you can see here, there is the list of the supported ones. So it doesn't support, for example, bring your own data or Sentinel tree. For EO Browser, first you go to EO Browser. I have the EO Browser home window open here. And we are in Discover tab. And here you see Themes. Currently default is selected. But if I log in to see, so here I can see all the official themes, but to see my own configurations, including the one that we just created, I have to log in. Okay, now I can see the agriculture monitoring configuration over here. I select it and then select the Sentinel 1C, Sentinel 2L1C data source, and I click search. When I visualize one of the images, I can then see my layers here on the left, just as it was with the Sentinel Playground. So what Sentinel Playground and EO Browser are doing here are taking the WMS requests of our layers that are specified over here. So let's go back to the agenda now. So next on the agenda, we're going to take a look at the OGC structure and examples. I am back on the Sentinel Hub website here. And to find the documentation for OGC, you will go under Develop, API, and then click on this OGC API orange card. So here you can see 4 cards. The first one, here you have the basic documentation for all the 4 different WMS, WCS, WMTS, and WFS. And these standard services are the parameters that other people are using as well. So they are standard. And here under additional request parameters, you can find the Sentinel Hub specific parameters that are also not required. Of course, under standard services, there are also some parameters that are not required. As you can see, statistical info service is separated here, is a little bit special. And then here is a very handy examples page that we're going to take a look at. So if you open this standard services up, and then we open up the WMS request, you get some explanations. And then over here, you have the parameters and how to use them. This is what you use for the reference for creating OGC requests. But right now we're going to move to examples, the third card, because here I'm going to easiest be able to explain to you how the OGC requests are actually structured. So to run OGC requests, you need to have a configuration ID. If we go back to the dashboard, into the configuration utility, you can see that all of my configurations over here have their own IDs. So these are very unique. And by this, the Sentinel Hub system recognizes that this is you. If we click on our configuration over here, here is the ID, and here is a very handy button that lets us copy this. Let's go back to the examples page, and we are going to put this in and refresh. And what happened now is that this URL over here got the instance ID added in it. So if I remove this for a moment, you can see over here that we have this instance ID in curly brackets over here. So this is the part that we are replacing with our ID. So the first part of any OGC request is actually a URL. It goes to services.sentinelhub.com in this case, because this data is situated on the services deployment. This specifies that it is OGC, and this that it is the WMS request. Then, right after this, we specify the instance ID, and then here is a little question mark that signals that the parameters are going to start. The first parameter that is mandatory is request equals get map. So each parameter starts with the caps lock, the name of the parameter, and then equals to, and get then the value of the parameter. To see which values and which parameters you can use, you can go under WMS request and then find the request. And here you can see which ones you can use. You can use get map, get feature info, and get capabilities. We're going to take a little bit more in detail what these differences are. But get map is the one that is going to return you an image. So this is the one that you want to have, get map in this case. Then this parameter is separated from the next one using the AND, as all the parameters are separated from each other with an AND. And then the next one is bounding box, where you specify the 4 coordinates. Then you have layers parameter, where the value of this layer is an ID of your layer in your configuration. So up here we have 3 layers. And if we want to display true color, we would grab the ID of this layer, which is not the title, but is ID which is below the title. So if we copy this and put it in here and click enter, we're going to get a result over here. So this is a very handy page that we built so that you can see the parameters over here and then change the values and see how it behaves. Next parameter over here is max cloud coverage, max CC, which is currently set to 20. If I would put this to 100, we would get a lot more cloudy image because it means that the permitted cloud coverage is 100%. Then we also have width and height. So how big of an image we want. We have a format. Also what formats are available you can see in the documentation. It's basically JPEG, PNG, and TIFF. And of course a time range. So this is all you need to know to work with the WMS requests. If I grab all of this right now, go into the new tab and put it into a URL, click enter, this is going to result in an image. So now we have made a WMS request, the same way as this page is doing it, and the same way as your browser is doing it. Another very handy tool that you can use is our request builder tool. which is our internal tool that we have released to the public, as it is extremely useful. So here you have multiple options, like for example, batch and process API, but the last one is OGC API. You have to be logged in to use it. And as you can see, we have only two options, WMS and FIS. We're going to select WMS. And then this is very handy, as here you can immediately select your configuration, agriculture monitoring, and the instance ID is going to be automatically read from that. Also, you can select a layer, like for example, NDGI, and the ID will be put in here. Here you have time range, height and width, or resolution. If you choose height and width, you have here to keep ratio automatically, so that the image doesn't get stretched, but it keeps the ratio of this bounding box. And here you also have the format. Now, the most useful feature of this tool, in my opinion, for OGC requests is specifically this bounding box tool. So you can just select any bounding box, and the coordinates are going to be displayed here. And you have two coordinate systems available. This one, which is the default. If you specify coordinates in this way, you are not going to need to specify CRS. And if you choose this one, this is a WGS coordinate system. Down here, you can also see immediately the updated URL. And if you grab this and go again into our page, click enter, you're going to see the result over here. And this is how you can use the request builder. Yes, so we have just grabbed this and put it in here, but of course you can just click send request, and then the request builder is going to return you an image. And if you click download the response, the image is going to be downloaded onto your computer. Okay, so the following thing that we're going to do, now that we understand this, we're going to take a look at all the other options of the OGC that we have. So WMS means Web Map Service and is used to display images for you. Then the next one we have is WCS, which means Web Coverage Service, and is very similar to WMS, but the data in WCS is more raw. So if you want to analyze the data and you do not want any modifications done to it, then you should use WCS. But if you only want to work with TIFFs, then WMS is going to be okay as well. So if we put in on this, for example, NDGI, click enter, we are going to see a WCS of the NDGI, and we could of course do the same thing using the URL or the request builder. Then the next one we have is WMTS, which is a web map tile service. And this request is a little bit special because what it does, it is going to be clear when I show you in QGIS, but it makes it possible for the tiles to be cached. So yeah, we're going to take a look at this later. Again, we can see the result. Then the next one we have, we're going to look at WFS. WFS is a little bit special in terms of the parameters, because aside from the request and the bounding box and time, such as the other ones, what it also needs is a type names. And type names is nothing complicated. If we go in the WFS request documentation over here, here is the table, and the type names parameter just requires the value that is going to tell the system which satellite this is. And if your data is on AOES services, which in our case is, then Sentinel-2 L1C should be using DSS1. So if we grab this, pop it into here, it is then going to give us a result. We're going to see a nicer result later in Postman. But what WFS does, this is the web feature service. You can think of it as a sort of like a catalog. You can request to give you information on all the tiles in a specific time range, and then it will return you which tiles are available in that time range and what are their properties. Then the last one that we have is a statistical info service. which also which gives you statistics. It gives you for the specific bounding box and the time range. It gives you the standard deviation, maximum, medium, and such values of reflectance values. Okay, next we're going to take a look at these requests in Postman. Postman is also a great tool for making OGC requests and a very easy way to make a request. So I am going to go for a second back over here, and I'm going to grab a WMS URL that is a working request already. I will go back to Postman, and I will click on this big orange new button, click request, and then I have to store it in one of the folders, which I already have OGC API selected here. Let's name it WMS request, save to OGC API, and then as you can see, here is the URL slot, and if you pop it in, you're going to see that similarly as on our example page, the parameters are very handily listed here, and you can easily change the parameters. To send the request, you click the blue send button, and the request is going to be sent. So we can easily now modify this. We can lower the cloud coverage. I put it to 20, and we can return NDGI over here, click send, and we will get the result. Now, if you want to remove the logo, you can go under in the configuration over here, and you can click that the logo is not shown and then save it. Okay, so for WMS, as we saw in the documentation, we have multiple options. So get capabilities gives you some information about which parameters are available, and it is simply run without any other parameters. So you just say request equals get capabilities and run it, and then you get this result. And if you look at that, at the beginning, we have some information on the Copernicus, then on Synergize, and then down here we are going to have the available coordinate systems and such information, and also the layers that we can return that are in our configuration. So similar is for WCS. WCS uses get coverage to get an image, and if you run get capabilities, you are again going to get information. There is also describe coverage, which is another type of information that you can get, which also has some CRS information inside. Again, WMTS uses get tile to get an image because it is a tiled system. Get capabilities again are going to return you some information. WFS, you write get feature to get the actual information on the tiles, and this get feature then returns you all of the tiles up there. Each of them has an information on the coordinates, the time range, time of the acquisition, and so on. And the amount of them depends on the time range that we have over here. Then statistical information can be done without the histogram, which is very simple. You just write which layer you want, the bounding box, the cloud coverage, and time and resolution. And then you will get, for each of the date, you will get minimum, maximum, mean, and standard deviation values. You can also compute it with the histogram, in which case you're going to need a couple of more parameters. You can take a look at this in the documentation, and then you are also going to get a histogram with a value for each of the parts in the the parts on the histogram, or on the position, what the value was at that position. Okay, let's check our agenda again. So we have now checked the structure of those and ran them in URL Request Builder and Postman. And next we are going to take a look at how we can integrate OGC requests into QGIS and ArcGIS Online. So I am going to go into my QGIS application. I have an OpenStreetMap over here so that I can see where I am. It is very important it is very important that you are zoomed in, as if you are not zoomed in enough, you are not going to see an image. So now we are going to import an image by going to layer up here, add layer. And as you can see, you have multiple options here, WMS, WMTS, then WCS and WFS. We're going to be importing WMS and WMTS today. So whatever is over here is from before for your previous import. So if you want to make a new import, you go under layers over here and create new. And now you're greeted with the name and the URL. Now we're going to go back to our dashboard. And here where we copied the ID of the configuration, you can also click on this drop-down button. And here you will see WMS, WMTS, and WFS and WCS options. And if you click on WMS, then the endpoint is going to be created for you. So as you can see, you are already familiar with this. It is the endpoint of the services, and then the instance ID. So basically, it is this part over here without the parameters. So now that we click this button and copy this, go back into QGIS, copy this in, and we can name it WMS import, click OK. And now we have to click on connect. And all of our layers in our configuration are now present here. If we click add, we can add them all. They're going to get added onto our left side over here. And as soon as they load, you're going to see them. All of them work. So the next one we're going to create is the WMTS. So I'm now back here in the dashboard, and I'm going to grab the endpoint for the WMTS by copying it and going back to QGIS, layer, add layer, WMTS layer. Then again, I will click on new, copy in the URL, WMTS import, OK, and connect. And now you're going to see that this looks a bit different. That is because this is the tile system that we were talking about. So for each of the formats available, you have different tile sets and coordinate systems. It's not that important which tile set you are using, but it is crucial that, it is the best if you're using the tile set which is also being used by QGIS. So for that reason, in our case, we're going to choose the popular web Mercator. Click on add. And as you can see, there behind, it has already been added. I am now going to add only one because this is all I need to explain you how it works. And if I zoom out a little, you can see what is going on here. It is loading tile by tile. So these tiles can be cached depending on the application that you are using. And this can then increase the efficiency of the loading of the image. So this is why you might want to use the WMTS in your application. Okay, then in QGIS, you can also do all of this, and even you have more freedom if you use the QGIS plugin. I'm going to delete these layers now. And I'm going to go under plugins on top, manage and install plugins. I will write Sentinel Hub, select it, and click install plugin down here on the right. It will be instantly installed, and up here on the left upper corner, you're going to see a little Sentinel Hub logo. And this is how you then open this plugin. If we click on that, you can see that the plugin has 3 tabs: login, create, and download. So first we're going to have to log in to this, and for this we're going to need client ID and client secret. Let's go back to dashboard so that I can show you how you can get your client ID and client secret. You go under user settings, and then you can see OAuth clients over here. We're going to click a little plus button over here, and we're going to name it QGIS plugin. We're going to select client credentials and click create client. Now this big code, the password is called a secret, and it is displayed to you only at this moment and then never again. This is for security reasons. So you copy this and maybe save it somewhere on your computer. Then go directly into QGIS and copy it in. Then we're going to go back and we are going to grab the ID, which is displayed over here, and is going to, this not going to go anywhere. It is here with you forever. Let's go back to QGIS and pop it in. Now if I click login, I'm going to be logged in. I can now go into this create and start making OGC requests. So let's select our configuration, agriculture monitoring. The available OGC requests are WMS, WMTS, and WFS. Let's stay with WMS. And here all the layers are already presented for us. Let's choose the barren soil. Here is the suitable coordinate system already done for you. You can select the time range, but I am satisfied with having on 1 month of imagery. Then this grayly colored dates show you on which dates the imagery was taken. So these dates actually contain the imagery. Here is also the mosaicing, least recent, most recent, least cloud coverage, and so on. And then I can use this configuration setup that I just created to update one of the layers over here, or to create a new one. I am going to create a new one. And here I can see it now imported. Okay. Then on the right tab over here, this is download. This is what you can use to download satellite imagery onto your computer. So you can choose a format. Like for example, we can choose TIFF. You can choose the resolution. You can choose whether you want it downloaded, what you can see in this window over here, current window, or if you want a custom bounding box, in which case you can input the coordinates. Yeah, whether you wanted the logo shown or not, which folder you want it downloaded to on your computer, you can also browse for this. Yes, and an important thing over here with OGC, the TIFFs that you can get are unsigned integers 8. If you want TIFF 16 or 38-bit float, you are going to have to use, you're going to have to create a version 3 eval script with the sample type that specifies this format, and then over here this one will be downloaded for you. Okay, so yeah, down here you have a download button to confirm the downloading to your machine, and this is it regarding the plugin. Let's go back to our agenda and see what is next. Okay, so we have ArcGIS next. ArcGIS is, I have it over here, ArcGIS Online. I'm going to go under Map. The process is very similar to as how you add layers into QGIS. You click Add over here, add layer from Web. In the drop-down menu, you select WMS OGC Web Service, and then you're going to be asked for the endpoint. So let's go back to our configuration and copy this endpoint and then pop it in. Get layers. And we already see all of our layers listed over here. We can select whichever we want. Now we have all of them selected and click Add Layer. Now if we click on this button over here, we're going to see our layers, but we have to be zoomed in properly. And then hopefully if we do everything correctly, the images should load for us. Yeah, there we go. So you can see that the imagery is loading over here. and also select the NDGI and check if it works. There. So this is how you do it in ArcGIS. Back to our agenda. Oh, so next we have an agenda is how to make requests using Python and our Jupyter Notebook example. Okay, I am going now to the Sentinel Hub GitHub page. So if you type github.com Sentinel Hub, you're going to then find our GitHub page where you can find a lot of useful information. But we're going to select the Sentinel Hub PI GitHub. And over here, you have all the documentation on installation and so on. So to install this, what I did to install this was use the Anaconda prompt, and then I created a local environment, and then installed all the Sentinel Hub, and then also all the other libraries that I wanted with the Python, such as, for example, pandas and so on. Over here you have examples folder where you have the examples, and if we open this OGC request over here, I have it already opened. This is going to explain to you in detail how to make OGC requests in Python. It is going to explain to you how to authenticate. So if you see over here, this part over here is the authentication part. Here is your instance ID, and over here between those little these little marks, you're going to put in your instance ID from your configuration. Then this part then checks if you have an instance ID or not. Then we are importing some things that are going to be using. So everything needs to be imported. For example, from Sentinel Hub, we import WMS request, MIME type, CRS, bounding box, data collection, and so on. Then we also need this plot image code, because in Python, you do not just get an image when you write WMS request, but you also have to display it especially. This is the area that is being dealt with in this notebook. So here the coordinates are set up. This is the name. And then here they are plugged in with also the coordinate system. This is then later going to be added into a WMS request. This part creates a WMS request. This is the name that can be anything. And then this has to stay as it is, as this tells the system which request it is. Here you specify which data set it is. Oh, this is your layer ID. This is your bounding box. You are calling it being defined up here. Time, which can also be a time range. Width, height, and this config is telling the system where to find the credentials for this request. Then the next thing that needs to be done is get data of this request. So you choose a new name, which could be whatever, and then you copy paste this part in and get method and add method get data. This is going to get this data, and then you plot the image of this get data that you got, and this -1 here shows that the latest acquisition, the last available acquisition is going to be presented to you, and then you get this kind of result. Now this plot image is defined up here, where you have the size of the figure, a number of rows, number of columns, so you can edit how this is going to look like up there. So if you scroll down here, you are going to find a lot of additional information. For example, how to choose the latest time acquisition, how to work with time ranges, how to add custom scripts, and so on. I'm not going to go through all this right now. I invite you to take a look at this yourself. In Sentinel Hub PI examples, you also have here the example for FIS request, which is going to teach you how to do statistics, and also batch processing and processing API and so on. Okay, now we can move to the example Jupyter Notebook that we have, which is over here. So this is the notebook that I have prepared. So as you may know, in the beginning of the year, the wildfires in Australia were extremely devastating. And I wanted to explore a little bit what can be done in Python. So this is a very simple notebook just to give you an idea. So first I have all the imports over here. Here are the Sentinel Hub imports and also other imports that I need, such as Seaborn, Matplotlibs, and such. The plot image is defined here. The credentials are defined here. This is my instance ID over here. And then I specified the bounding box as we saw before. Here I have an image displaying where this is in Australia. And then we can visualize this in true color by running the WMS request, getting data, and then plotting the image. I am now going to run all these cells so that you can see how this works. Now, if we wait a little, we see the result over here. This is the true color image. Then what I wanted to do in this notebook is to figure out on which dates the wildfire actually happened. Let's say that I know that in this area there was a wildfire, but I do not know when exactly. So I have set up here the whole time range of the Australia wildfires up to that time when I was doing it. And then I listed all the acquisitions in this time range using this code. So if I now run this, you're going to see it says these 9 images were taken on the following dates over here. Okay, but this does not now help me too much because I still don't know where the wildfire is. And to do this, what I did was use a FIS request to display the values of the Sentinel-2 bands. I know that bands 12 and 11 are highly reflected by heated areas, so I want to see how these bands react through time, and then I can hopefully notice the changes that would signify the wildfire. So this is the FIS request I have here. This is the bounding box is called here. The time interval is was set up here. This is where I want the data stored, the resolution, and so on. Then I get data again. And this part then is going to create this graph that you can see over here when it loads. Okay, so I have it actually already preloaded over here. It looks like it's taking a bit of time. So what this is doing is actually plotting the reflectance values from 0 to 1 over here for each of the acquisition dates. And you can see each one in its own color. And now this plot has multiple options that are set up over here. When you set up this plot, well, doesn't matter, but you have the option. Oh, here it is. You can choose minimum, maximum, mean, and standard deviation, for example. But then over here, we have chosen maximum. So these are the maximum values on that acquisition date for the bounding box. Okay, so now what we can see here is that on acquisition 5 and 6, values of band 11 and band 12 were extremely high. And we can now check for these specific dates whether there was actually a wildfire here. And this is exactly what we did. I used the Pierre Marcus wildfire script over here, which is a little bit nicer true color, but it also highlights the heated areas. And then I made another WMS request, and I input in his eval script over here. It was defined over here, and then it was input over here. Then the Python is actually very nice because it allows you to display data in such ways. And here I have displayed exactly this 5th and 6th acquisition and the next one. And over here, I'm not sure if you see this well, we can see the fires going. And then on the next image, we can see them a little bit less. And then here they're gone. So the next thing I did then is use a burned areas detection script that I made. And I input it in again. And then I ran the request again and displayed the same thing. And here we can now quickly see which area is actually burnt and how it progresses through time. So if you can see these 3 images, we can see that the burned area gets larger every day. Okay, the next thing that we have on the list is include satellite imagery into a web application using Leaflet. We're going to go back to the Sentinel Hub website, and we're going to take a look at the FAQ over here. We're going to go into FAQ, and then if you scroll down here, you can see integrate data into GIS and web applications. One of them is how can I integrate this service in Leaflet? Here you can see that you are supposed to go into the configuration utility, click view in Playground, and then click on that tool button to see the code for Leaflet. So let's do this right now. I'm going back to the configuration. I will click open in Playground, and then I will click on this integration tool in this upper right corner, and this window opens. So this code over here is the code for integrating Leaflet, and here on the left you also have Open Layers and Google Maps API. So if I click download this button over here, this is going to download all of this code. As you can see, it's a full HTML page. So if I download this and open this, you can see that this is actually through the whole page. I now got the Leaflet plugin, which I can zoom in and zoom out. And here are the layers. The base layer is OpenStreetMap, and the layer that was taken was the latest, was the uppermost layer that was in our Sentinel Playground. Okay, and now showing folder. Now I can grab it and put it in my Leaflet app folder like this. Now we're going to take a look at this Leaflet example, how this is actually structured. So as you can see here under head, some Leaflet links and styles were added. Then in body here you have div dev testing demo. This is the actual map that you can see, the div. And then down here under script you have a script. And first you have the OpenStreetMap defined OSM. It takes this OpenStreetMap layer. There's also an attribution that you can then see. Here you have Sentinel Hub WMS service with the base URL that you are already familiar with your instance ID. And there is also an attribution, and there is a user processing API, which we're not going to need because we will only be working with OGC. Here are then the parameters: maximum cloud coverage, zoom, preset, which is the layer ID, and the layers, and also the time range. Then down here, this code has separated base maps and overlay maps. The base map is the OpenStreetMap, and then up on that is the Sentinel Hub layer. And as you saw over here, this base map is always on. You can then turn on the other layers. So this is how these two are separated. Okay, so now if we wanted, now I have created over here a little application for agriculture monitoring, where I have the 3 layers that we have in our configuration described with images. And I would now like to have a window over here on the right displaying these maps so that the user can then toggle between them. So let's see how we can do this. We're going to go next into the code, and the first thing that we do, we're going to duplicate this code twice because each one is its own layer, and then we are going to rename them True Color, NDGI, and Barren Soil. Then we are going to input the true color over here. So these are the IDs that we have been inputting into this is the layer ID. Here they are. So we can copy this in. And then the second one is going to be the NDGI. Be careful about the commas over here and about the spaces. So we have now this set, and now all we need to do is add them in under here and change the naming. So I'm going to duplicate this twice because we have 3 layers. And I'm going to name the first one True Color. The second one is going to be NDGI. The third one is going to be Barren Soil. And then, of course, I need to grab the correct names. So true color is going to be this one. The NDVI is going to be this one. And then the barren soil is going to be this one. So this should now add these 3 layers and rename them above the OpenStreetMap layer. And the last thing we need to do is we need to grab this. We need to grab this code, and now we're going to move it into our application over here. I'm going to edit this with Notepad. I'm going to scroll down. I'm going to copy it in on below the script. We have these layers over here, and we have to grab the div over here, which we're going to put right under our accordion over here. So we can check the accordion like this and then pop it in right after this. And what I also did after adding also this styling over here is I also edited the styling. So over here in the original, the styling was put to 100%. So if I put this to 70%, the window is going to get a bit smaller. And here I have chosen, I have changed the height, the margins, and clicked float left, so that the application, so that the plugin is then going to be in the correct spot where I want it. Okay, now if I open this, I get this like this. If I zoom in enough, I should now see all the layers displayed. The bottommost layer over here is always the one that shows. And this is now our tiny little agriculture monitoring web application with Leaflet. I would just like to invite you to visit our next webinar, where we are going to be exploring processing API. And also, if you are interested in custom scripts, check out our previous webinar. And yeah, I thank you for your attention.
Thank you very much. So we can start with questions and answer section. We already tried to answer some of your questions in between, but let's read them out loud for the others as well. So Anna Maria was asking regarding a notification warning which she's receiving in our dashboard. So the warning says that the Sentinel 3, Sentinel 5 layers and others are processed on different infrastructure, which requires to use the right endpoint. So, and also we already tried to answer this one. So we have our data set on different endpoints. If the rest of participants can check also the chat, there are the links stated as well.
Yeah, so here on our data page, you can see for each data set what the WMS entry point would be. So for Sentinel-3, for example, this would be QGIS, and this way you would then access these other satellites.
And the reason why the links are not working without ending with configuration is that this is just a pattern that the request should follow. So this is why it's not working. Then we have the next question was from Cremena. She is asking regarding the polygons. And the question was if it is supported and which Jupyter Notebook explains its use.
So I think that if I remember correctly, the polygon should be explained in this OGC request notebook. Let me just check quickly. It looks like I closed it down before. Okay. So geometry. Yeah, so the geometry is a parameter. So it's a custom parameter that you can call in instead of the bounding box. So you would then call in this geometry and then put in the coordinates for the polygon. Yeah, it should also be in our documentation. If I go into OGC API, there it is under additional parameters. You can read a little bit more about that. We also have, no, those are processing API examples on the docs. Yeah, I hope this answers your question.
Then we have another question from Jonathan. He is asking if we can tell him if there is a script for Rstats existing.
I don't think we have any presets for R. So if you would do any R integration, you would have to do it yourself. Sorry.
Okay, thank you, Marco.
Regarding to this, we also saw some of you asking about the Snap integration. We also do not yet support the Snap integration.
Then we had the next question from Cremina. If she's asking if she can compare between images using NDGI, and if yes, which notebooks from GitHub she can check to learn how.
Compare. So your browser has a very awesome comparing tool where you can use the sliders to change the images. Otherwise you could do a similar thing that we did in the notebook where we returned images on different acquisitions, which was over here. And then you can compare them this way. I am not sure about another way. Maybe someone else could jump in. And of course, if you wanted NDVI, then the script you would input would be NDVI.
So Cremina is also adding to this question, she meant calculating PI 8 pixels by pixel comparison between scenes. The script, Monia, if you can check the last comment, the script may or may not exist yet. So
Yeah, this is possible. So if you're looking for a specific script, I would recommend you to check our custom script website.
Then we have another question from Jonathan, where will be published the webinar recording. So we will send you the link of the recording via email in the next couple of days. And the recording will be published on our YouTube channel and also shared on our webpage with webinars. So we will try to get the links to you via emails. Amit is also asking how can we build new indices based on combination?
So in your browser over here, you under custom down here, you have a tool where you can just return the band combinations or put the bands into the normalest difference or a normal index, which would then give you a result. You could also, of course, do this in a custom script, such as for the bands to return band 4, band 3, and band 2. But for this content, I would advise you to check the custom script webinar.
Okay, thank you, Munia. The next question also comes from Amit, and he's asking if we can extract time series information based on polygon or point.
Yeah, I think that would be possible. You have some information about the time series can be found over here. However, this is more meant for the processing API, but it will give you some idea of how to work with time series. When you are working with Python, it is advised that you actually work with the process API instead of OGC API, because it is a lot more powerful, and you also have all of the examples for there the same way as I showed you. It's also pretty similar to work with the processing API. Yeah, that's all.
So in this case, we waited a bit for extra questions. Otherwise, you can always write to us as well. As mentioned in the beginning, we will send you the link to the recording to the webinar in the coming days, and we will include in the description of this YouTube video also the relevant links from the webinar. I would also like to invite you to follow our social media for more updates, also for our coming events. And you can also state the additional questions on our forum. Maybe you will also find some answers already stated there. And one more invitation. Today we also mentioned custom scripts several times, so I would like to use this chance to invite you to submit your custom scripts to the Sentinel Hub custom script contest, which is still ongoing, and we intend to prolong it until the end of November. So this is giving you plenty of time to participate, and we are looking forward to seeing your submissions. Thank you very much for today. Hope to see you the next time as well. See you soon. Thank you, Monia, for your presentation.
Thank you, Sabina.